Python session specifically for scaling. All right. So the first thing that we need to know is that we are accustomed doing graphs, right? And you're accustomed to drawing the x and y axes.
Yeah, in physics.
Right. So you see, you'd see it more in physics. Physics is where the scales are most applicable. And math, in particular, you will see it a lot when you have to deal with statistics because you have graphs, right? Whether it's the histogram that we're dealing with right now, or when we move into the cumulative frequency curve, all right? The cumulative frequency curve and the histogram, we use these things to represent frequencies, right? And those frequencies don't necessarily range only from like 1 to 10 or 1 to 20. They sometimes go to 100 or 150, depending. Aside from that, the data we may collect as well doesn't only stay between, say, 0 and 20. It might range between a range of values, as we were looking at with one of the examples in particular, with weight. Weight isn't going to fit between 0 and 20 at all. Somebody's weight could range anywhere, depending on the age of the person. It could range anywhere between, say, 30 kilograms and up, right? And for these reasons, we need to use scales because sometimes, like I was saying, the quantity we're required to represent, it basically won't fit on a regular scale of 1 to 1. All right. So maybe back when you all were in Form 1 or Form 2 and even up to Form 3, you might remember using your Cartesian plane to plot points. And in plotting those points, you may have used a 1-to-1 scale, as in every centimeter on your graph sheet would have represented 1 centimeter, or 1 unit, I should say, for your variable, whatever you're representing. All right. And that's quite nice and useful when everything is of an integral value, as in just whole numbers or integers, where that data is easy to work with. But in particular for the histogram, I'm sure most of you would have noticed that you do have instances where you need to represent your data and you need that 0.5 when you have to find the class boundaries. And that 0.5 is not easy to see on most scales. And depending on the scale that we use, we'll be able to represent that 0.5 more accurately. All right. So today we're going to start back from the basics of using the 1-to-1 scale. Then we're going to look at another scale, and then we're going to go into the histogram part of things and look at the scale being used there, because not always are they going to tell us the scales. We need to be able to use our discretion at some point in time to identify a suitable scale. All right. And this is why it all plays a part in knowing what is the quantity you're representing on your scales. All right. So everybody has the examples copied down already so that we can start working on it, because I'm going to switch the camera in a little bit. So everybody has the example written down?
Yeah, miss.
All right. I hear a very vocal boy. Let me see. Okay, so everybody can hear me right now?
Yeah, miss.
All right, awesome. So here's what we're going to do, right? Sorry about that. So like I was saying, on my graph sheet, it's pretty simple for me to identify where 1 centimeter is, 1 unit. Some people, their graph sheets are a little different. It usually has dark lines at every 2 centimeter interval. So it all depends on your paper, but here's how you can identify your 1 centimeter divisions on the graph sheet. So you notice that your graph sheet is not just divided into these 1 centimeter unit blocks, but it's also divided into further tinier units. And these smaller ones, every time we count 5 of these, 5 of those would be 1 centimeter. All right. So from here, where my graph sheet starts, 1, 2, 3, 4, 5. 5 of these will give me 1 centimeter or 1 unit. So that's how I can identify it if my paper doesn't show it as clearly as this one does. All right. Now, depending on the data that you usually want to represent on your graph sheet, that tells you how you're going to, first of all, draw your axes, and second of all, scale. Now, the data I have, or I should say the information that I was provided with for the example involving the points, those points don't just range in a positive quadrant, they range in other quadrants of my Cartesian plane. And for this reason, I will prefer to divide my Cartesian plane into 4 quadrants. So I'll take my graph sheet and I'll probably go closer to the middle of the page, and I will draw my Cartesian plane starting from there. All right. So I know some people normally prefer to save space because, well, if you're using a scale like 1 centimeter to 1 unit, you don't necessarily need to go through the whole page itself. All right. So let's just check and see what are the values that the x coordinates range between and the values that the y coordinates range between. All right. So I'm just gonna pull up my doc. So the information I have is that the highest x coordinate on my list of points is 3, all right, positive 3. And the lowest possible x coordinate value is minus 3. So I want to make sure that my x-axis, when I draw it up, I can accommodate 3 and minus 3. Then when I look at my y-axis, I want to make sure that my y-axis can accommodate up to positive 5 and as low as minus 2. So for me, I don't necessarily need to use the whole sheet, all right? So what I'm going to do now, let me just see what I'm doing. Right. So what I'm going to do now, in this little space that I have here, I'm going to draw my axes. All right. So now, like I said, because I know my x-axis ranges in values from minus 3 to positive 3, what I'm going to do is count 6 units in the horizontal direction. So let's say I decide to come along here, right? I'm going to count 6. What am I saying? 6. 6 units. So 1, 2, 3, 4, 5, and 6, all right? So my x-axis will be along this line, all right? And my y-axis will run through the middle of it, all right? So from here, 0 would be at this line, all right? So 0, I'm going to draw my y-axis through where x is 0. And like I said, my highest y coordinate is 5. So I can count 5 units. 1, 2, 3, 4, 5. All right. So up till here. So I'm just going to draw my line now. So I just stopped off right here because I know my y-axis goes until minus 2. So this is where minus 1 will be. And this is where minus 2 will be. All right. So your pencil a little hard to see. I'm going to get a pen. All right. So back to what I was saying. So I'm going to label now. So my x-axis . So my x-axis is along this line, and I'm going to mark off each graduation mark and label it. So this is positive 3, positive 2, positive 1, and 0 is where my axes intersect. All right, and then coming across to the left, I have minus 1, minus 2, and minus 3. Now I'm going to do the same thing with the y-axis. I'm going to label my y-axis. and from the top, come down. All right, so I have 5, 4, 3, 2, and this is where 1 is. And then lower down here, we had -1 and -2. Right? So like I was saying, this is something that you all are very familiar with. You all would have seen this from since Form 1. All right? And once you have that understanding of what the one-to-one scale looks like, it's easy to plot points with that one-to-one scale. So you all could go ahead and do that. Now, what if I had decided to use a bigger scale instead? All right? A bigger scale, as in I use a larger number of units on my axes to represent a smaller quantity of my variable. So in other words, what if I decided to use 2 centimeters on my x-axis to represent just 1 unit? Then that would mean when I am labeling my axis, every 2 centimeters instead, I'm going to mark off 1 unit on my x-axis. So where my x-axis is, right? Let's just say this is where 0 is. I'm going to count 2 units from 0. So this is 1 unit, this is 2 units. And this is where, if I were to be using a 2 centimeters to represent 1 unit scale, this is where I would label 1 to be. All right. Now, let me just make sure I do this. Because scales are important, you also have to indicate what scale you're using. All right. So, for instance, because I use a one-to-one scale, I'm going to make note of that. All right. So the scales here, 1 cm represent 1 unit. All right. And because I use it on both axes, I'm going to just make note of that. Okay, so like I was saying, before you all met scales, these would have been pretty simple. This is what you all would have been doing before. All right, but now that you know scales and you know that you're going to have to represent larger quantities, understanding how you do your scaling is going to be very significant. All right, so for this one, like I was saying, you all could practice just plotting your points because this one is pretty easy to read off. But we're going to take a look at using a bigger scale because specifically when we had done the histogram and we were representing every 2 centimeters was 5 units, I realized that, some people had a little challenge identifying the exact location of certain points. And this is the reason why I said to myself, you know what, we'll do a little bit on scaling so you understand what's going on. But this is pretty much something you all have seen before, right? Everybody? You all have seen this before? Okay then. The silence is killing me. Can I move forward to using the 2 centimeter to represent 1 unit scale, anybody?
Yes, miss.
Grazie. All right. So let's talk about using 2 centimeters to represent 1 unit. Now, in certain instances, your data or your information, whatever you're going to be representing on a graph, it may require a larger scale or it may require a smaller scale. So the larger scale basically enhances the size of whatever you would have normally drawn. So here what we'll do, right? Just pause at some very obnoxious people on the road. Okay, so let's just get started with the other scaling, all right? So just give me a minute. Okay, so I'm going to use a different scale now. So here's what I'm going to do instead. I'm going to draw an x-axis where I'm using a scale of 2 centimeters to represent 1 unit. Okay, so I'm going to represent this same particular axis from -3 to 3, but I'm going to use a larger scale. All right, and let's see what that looks like. So I'm just going to come higher up here. All right, so from here now, like I was saying, on the x-axis, I'm using a scale of 2 centimeters to represent 1 unit. So first of all, I'm going to identify where I want my origin to be. And I'm going to let it run through the middle right here, okay? So I'm going to draw my axis now. So this is my y-axis. All right, now, here, every 2 centimeters is going to represent 1 unit. So if this is where 0 is at, like I said, I'm going to count 2 centimeters from here and label that as my first unit. So every 2 centimeters, now I'm going to label a unit. So this is where 1, positive 1 will be. I'm going to count 2 centimeters again. This is where 2 is going to be. I'm going to keep repeating that and pull up my axis, right? So I'm going to go to the left now. So on the left, 2 units, 2 centimeter units from 0 would be at this point. This is where I'm going to put -1. 2 centimeters away from that is where -2 is at. Then -3. All right. So what I want you all to notice here, look at that, right? This tiny little scale, 1 to 1, and this is my 2 centimeters to represent 1 unit, right? And look at how much more, like, it's more enlarged versus using this little tiny corner to try to plot points. Now, why would I want to use a larger scale? Anybody want to tell me why would I want to use a larger scale?
If the numbers are very big.
Okay, just a second. All right, so you said if the numbers are very big. So, I like that answer, Isha. So, yes, that's it, the accuracy of it, okay? Pertaining to what you mentioned, Lindsay, you would use a smaller, when I say smaller scale, it means that you would use 1 centimeter unit to represent a larger quantity. So that way the graph becomes smaller and will be able to fit there. So like I mentioned here, this 2 centimeters to represent 1 unit, look, the sunlight, it's the golden hour. Anyway, yeah, look at that. It enlarges my axis and I get a larger space to represent 1 unit instead. All right, so this one is going to give me a better accuracy, as Ravisha said. And in your case, Lindsay, if you have larger numbers, you would want to use something that will make the graph smaller and it will fit much better on your graph paper. All right, so when we talk about the accuracy now, this is where plotting the points come in. All right, so here's the reason why I really saw a lot of trouble with the histograms, right? Now, most people, yes, you can draw your axes quite well, label them beautifully, but then here's what happens. When you actually start plotting points, that's when the chaos started to happen. All right, so let's start with this one. I have a 1-to-1 scale here, all right? Using a 1-to-1 scale, if I were to ask you to identify where 1.5 is, that's where I realized reading scales is a little bit of a hassle. All right. Now, as I mentioned, when we were doing one of the histograms, if I were to use 1 centimeter to represent 10 units, which was one of the scales we used on the x-axis, it's pretty hard to find something like 9.5. It, as a matter of fact, it is so tiny, it is negligible, that it looks like it's exactly on 10, which is why I said I could give and take with the accuracy there. But let's look at this one with 1-to-1. Anybody can tell me that they can easily find 1.5, for instance, on the x-axis and label it accurately? So if, all right, let's just say I wanted to plot the point 1.52. Finding 2 on my y-axis is pretty simple, but finding 1.5 on the x-axis, we have to rely a little bit on eyeballing it and say, well, okay, 1.5 will be somewhere in the middle here. So it's around there. And then go to our line where 2 is, and we'll label somewhere around there, somewhere in the middle there, right? Now, in a case like that, yeah, sure, it is all right, but you would not necessarily get the accuracy out of your graph using a 1-to-1 scale like this. Far less for a 1 centimeter to represent 10 units. All right, so that's why I said the accuracy I could give and take with those smaller scales. But when I come to my x-axis, where I use 2 centimeters to represent 1 unit, identifying 1.5 is much more easier, right? And yes, I stress, much more easier. Anyway, why is it easier? Because, as Ravisha pointed out, it's more accurate. And why is it more accurate? Because it's a lot easier to find those little small units. So for instance, if you were looking at a ruler, you could find where 0.5 centimeter is, all right? Because they give you the millimeter markings. So when you create your axis, you should be able to read your axis as though you were reading a ruler, whether it be a large scale or a small scale. And in particular, for this one, where we use this 2 centimeters to represent 1 unit, finding 1.5 is much more easier for me because I have to simply count the little tiny unit blocks, these little tiny ones here. I count 5 of those, and I'll be able to find where 1.5 is. Because here, between 1 and 2, I have 10 units. And these 10 units will represent, for instance, like I was saying, a ruler, that would represent something like what a 1 millimeter would be. So finding 1.5 on this scale is so much better for me. I could just simply locate 1.5, which is around there, right? So this is where 1.5 would be. Now, like I was saying, different situations require different scales, and different scales gives you a different degree of accuracy. So, in a case like this, you get less accuracy, but for people who like to save the trees, you use less space on your paper. For people who want accuracy, not necessarily that they don't care about the trees, but they get more accuracy, and they can actually find half, like 1.5, or even to some extent like any decimal of these integers here, right? So if I wanted to find, say, 1.3, I can actually find where 1.3 is much easily in comparison to using a 1-to-1. All right. So like I was saying the other day with the assignment with the histograms, right? This is for McGill specifically. I realized that, some people have a few little hiccups here and there. And especially too when we talk about what you call this thing, broken scales, right? So one of the reasons for broken scales in particular would be trying to represent data that you have values starting pretty much later on. So for example, the histogram data that we had, that histogram data started at probably somewhere around 130. And this is the reason why you wouldn't want to go from 0 to 130, forcing yourself to use an entirely tiny scale, and then realizing, I didn't need 0 to 130 in the first place. I could have started at 130, go up. So I'm going to pull up a document a little bit. So just going to pause the share screen here. So let's look at this document. All right, so everybody can see this wonderful assignment. we're not looking at the first one because the first one didn't need a broken scale. We're going to look specifically at the second question because it required not just a larger scale, but it required that broken scale that we're talking about, right? So just give me a second. The disadvantages of living by the road. Anyway, question 2 here. So everybody can see the documentary. Nobody is having any issues with seeing anything on the screen.
Yeah, Miss, I see that.
All right, next. So, question 2. A frequency table recording the heights of 50 children is shown below. So it was height, not weight. So the heights, notice, they measure the height in centimeters, and the heights range from, beautiful. Right, and the heights range from 130 all the way to 164. Now, our data, like I was saying before, ranges all the way up to 164. However, it doesn't start at 0, it starts at 130. That was our smallest possible value they recorded. And for this reason, I don't necessarily have to use a scale that goes from 0 to 165. I can use a scale that starts at 130 and ends off at around 165, all right? And this particular scale I'm talking about is called a broken scale. So to do the broken scale, it's as simple as this. You're going to indicate your broken scale by using a little zigzag, all right? So which scale am I going to have as a broken scale, people? Which one? Which axis am I using a broken scale on? Am I using it on the y-axis or on the x-axis?
X-axis.
X-axis, right? So most times I prefer to keep my paper like this. In some instances, you may prefer to shift it to landscape versus portrait and use a larger scale if necessary. But I'm going to keep it like this for a while, and I'm going to start by identifying where my x-axis values range from. So I'm starting from the extreme left corner of my paper over here. So this is where 0 is at. Just give me a second. So let's start. So like I said, I'm starting from the extreme left corner. This is where 0 normally would have been. All right, but because I am using a broken scale, I'm going to do this little fancy zigzag thing. So it goes up, comes down, goes up like that. So it's like a Z. All right, so y'all can see that there. This is how you represent your broken scale. All right, just a little zigzag, nothing too fancy. All right, once you do that, that tells whoever is reading your graph, your scale is not going to go from 0 all the way up. It's going to skip out some values and then start. So wherever you decide to start your scale, I mean, when I say start your scale, I should say start labeling your axis. All right. So wherever you decide to start labeling your axis from, just remember what value you want to start at. For me, I want to start at 130. So I will come up here. So like around here, I'll label here as 130. All right. Now, 130 to 165. I can use any scale I want. I could probably say, well, every 1 centimeter, will represent 5 centimeters on my x-axis. So here would be 135, here would be 140, here would be 145, here would be 150, 155, 160, 165, 170. All right. So you can do that if you like, or you can. Or you can use a larger scale if you like, right? It's all up to you. But you have to know how much space you have on your paper and whether or not you will accommodate it easily, all right? So let's say I decide to go with every 2 centimeters, I'll represent 5 units. Let me see if I'll get that to fit. 135, 140, 145, 150, 155, 160, yeah. All right, so let's go with that one, right? Every 2 centimeters, I'm going to represent 5 units. So this is 135, This is where 140 is at. 145, 150. So just take notice of a few things here. The convenience of a broken scale. And the second thing is the fact that it gives us the opportunity to use an even larger scale to represent our data on our x-axis, so it gives us greater accuracy. And when you have large quantities, like Lindsay mentioned earlier, you have large numbers that you want to represent. This is a type of thing that normally would use a smaller scale, but because of the convenience of being able to use a broken scale here, we could use this lovely large scale and get even greater accuracy, specifically when it comes to the histogram, because you all know the histogram, we're going to use it to find the mode. And the accuracy of our histogram determines how accurate our mode will be. And in reading off the values accurately, to an extent that will influence how you'll be graded, all right? Because sometimes reading off a graph, the CSEC, the markers will be looking for your ability to read the graph and sometimes the accuracy, degree of accuracy to which you can do that, all right? So that is why in certain instances, you may want to use a larger scale to make it easier for you to read, or just simply for plotting points, all right? So now we're going to talk about plotting the points to create our histogram. So when we first started off doing the histogram, there was a lot of confusion in terms of how we're going to create the histogram in the first place. All right. I had a lot of people who got the general idea of the shape of the histogram, but the problem resided in being able to label the axis. Because in labeling the axis the way some people did, we wouldn't be able to find the mode. All right, we'd have some difficulty with finding the mode if we labeled it like if you were labeling a regular bar chart. So this is why make sure you understand how to label your axes and how to use appropriate scales. All right, so now that we have our x-axis, let's do our y-axis. So look at the values for the frequency. We know that our frequency will always go on the y-axis when it comes to statistical graphs, right, people? Yay or nay?
Yay. Yes, yes.
All right, good. So let's look at the values for frequency. Our range of values go from 2 up till about 19. 19 is the highest frequency. So for this reason, you don't need to use 1 centimeter to represent anything like 10 units or 5 units. You could probably use a 1-to-1, depending on the length of your page. You might get 22 blocks on your y-axis. Or if you want to, you could use a different scale. All right, but for this one, in particular, we could use 1-to-1. So on our x-axis, every 1 centimeter, we can mark off 1 unit. All right, so I'm going to mark off the y-axis now. All right, I'm kind of lazy to label the numbers, but you know what I mean, right? So 1, 2, 3, 4, this is where 5 is at. 1, 2, 3, 4, 5, 10. Now, for people who do physics, sciences, you all would know that scales for your graph are really important because generally you want your graph to take up at least 50% of your graph sheet. All right, and especially science people, accuracy and precision mean a lot to science people. All right.
Yes, so say I take 3/4 of your page.
See? So this is why you must understand how to use scales properly. All right. So in a little bit, we're going to plot points. Now, I know for some people, these things seem sort of minor because you're not really using this in everyday life. Like, who gonna tell me plot a histogram, right? Nobody really. So the thing that I want you all to do, at least from this session, is take away the importance of graphs and scales for you all Because as a mathematician or student who is doing math right now, you will want to make sure that you understand these things because you get marks for these things. All right, you'll get marks for these things. So let's start with plotting the graph itself, the histogram. All right, so my handwriting a little fancy, but this is my y-axis. I went in labeling the 5s instead because I know every 1 centimeter is representing 1 unit for me. Now, okay, so my x-axis, I'm using that for height in centimeters. All right, so always make sure, aside from choosing appropriate scales and drawing your axes, make sure you label them so you know which one is your x and your y. All right. Some people sometimes confuse the axes and whatnot. This is why you must label your axes. So you know, on the x-axis, I'm going to look for height. On the y-axis, I'm going to look for frequency. And let's talk about the histogram, all right? So I'm a little after 6. I don't want to keep you all too long. So let's just talk quickly about the points in terms of what points are we going to plot to create our histogram. And I think from here, this should help everybody understand on what better, how to create the histogram for future reference.
So, Miss,
yes,
question, right? Histogram is like one of them curve, the curve?
No, the curve is the cumulative frequency curve. The histogram is the bar chart looking thing, but the bars are connected to one another. You generally use your histogram for continuous data. And from your histogram, you can construct a frequency polygon. That's basically about it. Your histogram is more or less used for group data because you want to get the mode from it. And generally, an application of the histogram is to get the shape of your data spread. Now, that's something that math people wouldn't necessarily investigate too much. But for people who do add math, you are going to be using the shape of the histogram to tell you things like skewness of your data, so you know how your data is spread out about the mean and whatnot. We're not going to go into the details of that because, like I said, the math aspect of the histogram is for you to know how to plot the histogram, how to get your frequency polygon from it, and how to get your group data mode. Don't be sorry for them. And math students have more fun with stats than anybody else. Unless, of course, you decide to go and study stats beyond. But yeah, statistics is really nice in math, and once you like statistics, because it's one of the better topics in terms of application to real life, you wouldn't have too much of a hard time, all right? So let's get started. First of all, I labeled my axis for my data. My next question is this: what am I going to plot? Anybody could tell me what am I going to plot to create my histogram?
The points.
The points. Now, what points am I going to plot? Where am I going to get the points from?
From the information that was given,
Okay.
such as the scores and the frequency.
So I have a question now. Anybody else want to answer that for me? Can I plot 130 to 134 too?
No.
No. That's it. So what am I supposed to actually obtain before I start plotting my histogram points? Anybody remember me emphasizing the other day there's a significance between this value and that value? And I said there's a significance for knowing the terms in stats, such as your limits, your class limits, and then your class boundaries. Anybody remembers me saying that?
Me, kind of.
Remember something. The limits will tell us the values that go into the class intervals. But because we want to create that continuity, we have to create those class boundaries. And that is where we're going to get the points that we're going to plot to create our histogram. All right. And the reason why I say plot is simply because if I tell people create a histogram using the information from the table, they're going to draw me a bar chart. I want you all to get into the idea of understanding that when you're going to do your histogram, you must get your class boundaries, which means your lower class boundary and your upper class boundary. So can anybody tell me how I'm going to get my lower class boundary for just the first class, for example, and how I'm going to get the upper class boundary for that same class. So we have 130 to 134 as our first class interval. How am I going to get the class boundary? So I want somebody to tell me how I'm going to get the lower class boundary, and then somebody tell me how I'm going to get the upper class boundary. Anybody?
-5.
Okay, so we're minusing 5. Somebody says we're going to minus 5. So which one are we minusing 5 from, and which one are we obtaining by minusing 5?
So by minusing 5, you'll get the lower boundary, or the lower limits, and adding 5, you'll get the upper.
All right. So before continue, anybody agrees? Okay, anybody agrees or disagrees? Tell me. Is it 5 or 0.5? Which one should I be doing?
Sorry,
Decided to do
0.5.
0.5.
0.5. So I disagree with myself too.
I wanted to know. I know I didn't tell people 5. 0.5. 0.5. 0.5. And trust me, like I was saying earlier, when we use a 1 centimeter to represent 10 minutes, that sounds so insignificant. You can't see a 0.5. You can't tell the difference between a 0.5. But in this scale in particular that we have here, you will be able to identify where that 0.5 is much better. So the first thing is obtain your lower class boundaries by subtracting 0.5 from all of your lower class limits. So for each class interval, the first value that you see in the class interval, you're going to subtract 0.5. So 130 minus 0.5, 135 minus 0.5, 140 minus 0.5, and all of those are lower class boundaries. How am I going to get the upper class boundaries before I let you all go do the subtraction? How do we get the upper class boundaries?
Plus 0.5.
Yes, plus 0.5. All right. So what I want you all to do, you all can take your time. I'll check and see if I have the permission set to let people do annotations on the document. Well, right now, and once you all can do the annotations, I will want somebody to insert the lower class boundary, the lower class boundaries, and the upper class boundaries for me. Anyway, just now, I was supposed to check to see who could annotate. Somebody just try to scribble on the document for me, please. Yeah, anybody just try to scribble on it. Okay, thank you, Bruce. Clean up your mess, thank you. All right, so.
Welcome, miss.
All right. So when you're ready, you can annotate. So you just go next to the class. So on the left-hand side, I want on the left-hand side of the table, you'll put the lower class boundaries. On the right-hand side of the table, just put the upper class for me. And once we do that, I'm going to show you how to plug points. And that'll wrap up our session. All right? Don't want to keep you all too late. But thank you all very much for bearing with all the interruptions and everything. Okay. So everybody, anybody who want to start putting the lower class boundaries for me, you can go right ahead. Feel free. Don't be shy. Just right away.
Yeah, miss.
Yes, Bruce.
You can explain how to do it again, please.
Okay. So from your lower class boundaries, you are going to your lower class limits. Sorry. To get the lower class boundary, you're taking your lower class limits and you're going to subtract 0.5. So my first lower class boundary, anybody want to tell me what they get for the first lower class boundary?
129.5.
Yes, that's it. That's it. So you want to go ahead and put the annotation in for me. You can go ahead and write in the 129.5 somewhere right here. Whether you choose to type it in or you choose to just draw. Anyone? Go ahead. Thank you. It looks very beautiful. Okay, who's next? Who wants to do the upper class boundary for me for the first class interval? So I see Bruce gonna write. Bruce, you're gonna write. You're gonna insert the upper class boundary for me. Come across on the side.
Yes.
Yeah, what happened?
I'm trying to type it, but it wouldn't thing. You just show one, apparently.
That's all? Just a second. Okay, yeah, go ahead now. Chat person. Alright, so if you get in a little trouble, I'm gonna use my retarded drawing and try to fill it in. Alright. So first tell me, what did you get for your upper class boundary?
It's 1.5, miss.
You sure 1.5? Anybody wanna help? Your upper class boundary, you have to add 0.5.
I believe he has to add a 0.5 to the highest number between 130 and 134. So yeah.
Okay, so we're gonna add 0.5 to 134. What should we get? Anybody wanna tell me?
134.5.
Beautiful. Thank you. So please excuse my beautiful handwriting here. I'm very artistic, as you can tell.
I don't see it.
Beautiful, isn't it? It looks like B4.5, but all right. At least we got it in. So we have 134.5 for the upper class boundary, 129.5 for the lower class boundary for our first class interval. Okay, so thank you whoever typed in that 139.5. So basically you'll get the yes to Joshua, who just raised his hand.
Miss, that was a complete unutter mistake.
Oh,
my God. I do not know the answer.
All right, no problem. So anyway, for this one, we're gonna do the lower class boundary, correct? So this one is going to be, what is the value for the lower class boundary? Anybody want to tell me for the second class? What is the lower class boundary going to be?
So let's it to be 134.5 then.
Yes. So, quick thing to point out, and I do believe my girls will remember me seeing this. The lower class boundary of my new class or my successive class is going to be the same as the upper class boundary of my previous class. So always you will notice these two values will coincide, and this is where that connectivity in our histogram comes from. So I'm just going to plot those 4 points, create the bars, show you how to plot the points and where that continuity comes from. All right. But once you all get the trend with finding the lower class boundaries and the upper class boundaries, the idea from there is just knowing how to plot the points, reading it over accurately here, and simple as that, you'll just be able to draw your histogram. All right. So let's talk about plotting the point itself now. So the first point I want to plot is 129.5. Now, remember, my scale is a little different this time. So let's just take a quick check on this, right? So let me just adjust the camera a little bit. Okay. So on my x-axis, I've used a scale of 2 centimeters to represent 5 units, which tells me that every 2 of these little blocks will give me 1 centimeter. So if I want to find out where 131 is, 131 will actually be here. So let me just raise that up a little bit. So this is where 130 is, everybody. 130 is here. 131 would be, notice, 2 little blocks away from 130. So this is where 131 is. And this is how you'll be able to count and find those 0.5s to actually accurately plot out the points that you need for your histogram. So this is where 131 is. I'm going to just put in the marks for between 130 and 135, so you all will see what I'm talking about. All right. So this is where 130 is. We have 131. Next 2 will be where 132 is. Then we have 133. And 2 blocks again, 134. So notice this. as I was mentioning to some of the girls who were having a little trouble with doing the axis, you want it to look almost as though you have a ruler on your paper. So notice here I have my major marks and then I have my minor marks. So my minor marks are where every 1 centimeter of my quantity is being represented. All right, and notice I said 1 centimeter of my quantity. Okay, so if I want to know where the height 131 is, the height 131 is over here. If I want to know where the height 134 is, the height 134 is over there on this line. Make sense?
Yes, miss.
Yes, miss.
Okay. So now let's talk about plotting the point 129.5. So earlier I asked, what am I plotting? I'm going to plot my lower boundary with the frequency corresponding to that class, and I'm going to plot my upper class boundary with the frequency of that same exact class. Okay, so this is going to give me the top of my bar, and that's how I'll create the first bar for my first class interval. So let's see, 129.5. Now, if I mentioned, like I mentioned, every 2 of these little blocks represent 1 centimeter. 129.5 would actually be this one little block just before where 130 is. Do you all agree with me?
Yeah, miss.
Yes, miss.
Any questions before I continue? I just need to make sure you all understand what it is happening.
Oh, miss.
No questions?
No, miss.
Okay.
Miss, are you going to calculate like the modal class?
Okay. Modal class, we'll talk about that in a bit. And I just want to show you all the histogram itself. All right? So, well, not the histogram, but the idea of getting the histogram. So this is where 129.5 is. So what I'm going to do, I'm going to plot my frequency of 2 with that. So the point 129.5 with a frequency of 2, 129.5 is along this line, and 2 is along this line. So this is where I will put my first point. All right. So this is where the height of that first class interval bar starts. Don't take you also. So 129.5, 2 is this point. Everybody can see the point?
Yeah.
Yes,
Yeah?
miss.
All right. So now I'm going to do the same thing. I'm going to do 134.5 with a frequency of 2. So 134 is this line here. 134.5 will be this block just before 135. Just before it. So I'm going to plot the point 134.5, 2. So that's where it will be. I'll just darken this spot. There. Okay, so these 2 points gives me the top of my bar. So all I'm going to do to create the bar, connect the tops, and then connect it coming down to the x-axis. All right, so create my first bar. Now this way, if you know how to get the class boundaries, plotting the points like this and then creating the bar might be easy for people who understand how to plot coordinate points, all right? Rather than make you go draw some bar charts again. All right, see, there we go. My first bar is created. All right, so this is my bar. This is what it looks like. Okay, notice I did not label it 130 to 134. If you want to do that, you can label it at the top preferably, but just to not confuse yourself, make sure your axis is nice and clear so it's easy for you to read. Are we all okay so far? Yeah?
Yes, miss.
Yeah, miss.
So all you need to do, like I said, find the lower class boundary, plot that with the corresponding frequency for the class interval. Repeat the process with your upper class boundary, and then just like we did here, connect the 2 points for the top of the bar, and then connect them coming back down to your x-axis. Now, because the 134.5 is repeated for the lower class boundary of the second class, all you're going to do is along the 134.5 line, you're going to locate where the frequency of 6 is and create a point. Stay noisy. Create the point. 134.5, 6 is up here. All right, and then 6, 139.5. So you notice how easy it is to find these 0.5s with this larger scale. right? So I can do this for all my classes if I want to, but I will just stop here. I just want to show you all the connection with the bars, how you create the bars in the first place. And now somebody mentioned modal class. So all I want to tell you all is that when you have to identify your modal class, it's easy to do because all you have to do is find the class that has the highest frequency. All right. So in this particular example, if I look at all the class intervals and I compare the frequencies of each class interval, I'll notice that one class has a very outstanding frequency. All right. And that frequency is 19. So this is what my modal class is. My modal class is a class interval 140 to 144 because it has the highest frequency. So remember the term mode, even from the basics of stats, you all know mode to be the most popular one. It still applies here. It's just that now because you're dealing with class, you're dealing with group data and you have class intervals, you have to know that there's a difference between the modal class and the actual mode. So for my girls, we're going to be dealing with the mode tomorrow. We're going to be dealing with mean tomorrow, group mean. Okay? And that's why I left the notes with you all to read up ahead of time to prepare yourselves. So tomorrow we'll see how we fare with that. So I have a minute left. Are we all comfortable with this from today?
Yeah, miss.
Yes, miss.
My other people, y'all okay?
I guess so.
Setting you sleeping.
Probably. Well, this session is recorded, so even if they were sleeping, I'll send them the link.
No, I'm not sleeping. I just saw that stuff.
Oh, okay. Anyway, thanks for joining, people, and thank you for all the time.